All right, so in this video, we're going to look at to check to see if two rectangles are overlapping. I'm going to go through some theory about how we would know if the things are not overlapping, and then we'll get into some code. All right, so you can skip ahead if you want to just get to the code, but it's not going to make a lot of sense, and it's going to be hard to hard to find any errors if you don't understand how it works. So the first thing I'm going to ask you, if you ask me to help you with your code, I'm going to ask you, well, did you watch the video? Did you understand what it was saying? Okay, so what we're going to do in our code is we're going to look for all the ways. We want to check to see if two things are overlapping, if they are colliding. We're actually going to do this in kind of the opposite. We're going to find ways where the rectangles might not be overlapping, and then we're going to use that information to say, well, if all these conditions are not met, then the rectangles are in fact overlapping. So, all right, so let's just look through. We have some rectangles here. We have the center one. The biggest idea we're going to look at here is left edge, right edge, top edge, bottom edge. We're going to look at that for a lot of different rectangles, compare some values to see when two things would overlap or not. Let's start with our first way that we could know that two rectangles are not overlapping. If the right edge of our rectangle is to the left of the left edge of our target rectangle, so our kind of like this A, the right edge is to the left of the left edge of this one, there's no way they could overlap, right? Because A would be somewhere there's just no way they could overlap. A would have to be, it could be anywhere over in this left segment of our picture, but there's no way for those to be overlapping, because in order for them to overlap, the right edge of this rectangle would have to be somewhere inside of our center rectangle. But based on this, if we're saying the right edge is to the left of the left edge, that's just not possible. So one way we could know that they're not overlapping is we could check the right edge is left of left edge. Let's say, I'm going to put some numbers in here. I'm going to call this triangle or rectangle 1, call this rectangle 2. So we could say if number 2's right edge is to the left edge of number 1, then they're not overlapping. That's one way. We know for sure automatically. Or we could say, maybe for example, in part B, we could say, for example, if the bottom edge of our rectangle is above the top edge of our kind of target rectangle, also that would be evidence there's no way that these two things could overlap. So we could say that, I'm going to call this 2 again. So if the 2's bottom edge is above top edge of 1, that's another way. There's really going to be 4 total possible ways this could happen. And I think hopefully you're starting to see a pattern here. Another way that we could look at this is if, for example, we'll call this again 2, just to kind of reiterate that we're looking at one rectangle, the different locations it could be. Again, we could look at now the left edge. If 2's left edge is right of 1's right edge, that's also, again, more evidence that they would not overlap. The fourth and final way that we could check to see if they're not overlapping is, well, hopefully you kind of guessed it by now. We're going to look at this one at the bottom, and we're going to say its top edge should be below the bottom edge of that center rectangle. All right, so with that out of the way, basically these are all the ways that we could say that our rectangles are not overlapping. However, if all 4 of these are not true, then we can kind of come to the conclusion that, in fact, the two things are overlapping. These are the 4 ways they could not overlap. If all 4 of these things are not true, well, that kind of leaves us with the only option is that they are, in fact, overlapping. There's we could talk a little bit more if you want to talk more in detail about this. We can, but it's just kind of these the ways they could not overlap. If none of these criteria are being met, then the two rectangles are going to have to overlap. So let's write some code for this. Okay, I have a bunch of code written already for this. I'm trying to make this video short as possible. I'm going to have a couple rectangles. I am kind of declaring those rectangles, initializing them here, setting up the size, and then in this case, I'm just having make sure they both display, and I'm having their location kind of move around based on my mouse. Okay. All right, so now we need to add in our next step is going to be checking for collisions. So let's do that. All right, so I wrote my method here called rectangle or rect collision. And it's going same as our ellipse. We're going to return a Boolean value to see whether they are actually colliding or not. And so what I'm going to do here is I'm going to do a series of ifs and if else's. So I'm going to say if, else if, These are the 4 ways that these things could be, 4 different ways they could not be overlapping. So I'm going to say if any one of these are true, and we'll get into like what's actually going to be in there, we're going to say they're not overlapping. Okay. In case this wasn't clear, these 4 things, these 4 are kind of corresponding to these 4 things. So we want to add this code into there. And then at the very end, we're going to say if none of those things are true, well, then clearly they're not overlapping, so they must be overlapping. All right, so let's look through here. We're going to try and write in this code. We're going to say if the right edge of our rectangle is to the left of the left edge of our other rectangle. So in our code, we're going to draw in a couple rectangles. If we draw in any of our rectangles, when we're talking about our, we're going to have our x and y values are going to be up here. This is going to be, let's see, so left edge is just equal to our x value. That's going to be like whatever this value is. The top edge is going to be our y value, right? Determining what's up here. Let's see, right edge. This is our left edge. Our right edge is going to be x plus the width of the rectangle. Okay. Similarly, the bottom edge is going to be y plus the height. Okay. That's how we're going to determine kind of, that's how we're going to find the edges on our rectangles, kind of based on the coordinates. All right, so if I want to do this, I want to check to see if the, where are we at here? I want to check to see if the right edge is to the left. Okay, so let's see. In our code, that means the right edge. So I'm going to say rect1 dot, we said it's going to be our x value, get x, plus rect1 dot get width. These 2 things combined are going to be the right edge of rect1. We want to see if those 2 values are to the left of the left edge of our this thing. So basically we want to see if this thing is to the left of this. That means that it has to be smaller. The right edge value has to be smaller than the left edge from our other rectangle. So let's say this is the right edge. This has to be less than rect2 get x. Okay. Let's test this out for a second. Let's just see if this is going to work. So hopefully we can build some confidence that this is actually going to work. We're going to do the same thing. Hopefully you watch the other ellipse video. Let's just see if we can get this working kind of like piece at a time. I'm going to say if rect collision. We are going to change, let's say rect2 dot set fill. We'll do random 255. Oh, wait. Yeah, this will kind of work. I'm not sure if it's going to show it very well. It basically, like, it should be flashing all the time because we're detecting a collision unless this is true. So if our, let's see. So if our rectangle is to the right of this one, it should not be detecting a collision. We haven't really accounted for when the thing's above it or when it's below it or when it's to the right side, but we do have it working when it's on the left side. So we can see this kind of play out as we write our code. Okay, let's add in a little bit more. So right now, basically, we're only focusing on the left side of our rectangle. We haven't done top and bottom. Let's work on, for symmetry, we'll try the right side next. So let me uncomment some of these things. I'm just going to do a little organization here. All right, so we need to do in here, yeah, we'll do the right side. So the right side looks like this one. The left edge is to the right of the right edge of the other one. Okay, so that means that like this edge, the left edge of number 2, is going to be to the right of the right edge of this one. So because that means this value should be greater than this value. So let's get the left edge of number 2. So that's going to be rect1.getx. And we want to check to see if that is greater than this x value over here. This x value over here is going to be our other rectangle, rectangle 2. I know I'm like messing up the numbers. If I had more time, I'd go back and fix that. But is greater than, that rect2 is going to be greater than, excuse me, the rect1x is going to be greater than rect2x plus its width, because that's really what's going to determine the right edge. So we can say rect2.get width. Okay, we're going to return false. All right, let's try and run that again. We get closer and closer. All right, that's working. Go to the right edge. That's working. Of course, top, bottom are still not working, but we're getting pretty close. Okay. All right, so what else do we need to add in here? All right, so let's do our top next. Or we'll just look down our list. We'll do the bottom edge next. All right, so we're going to look for, and that would be this one up here. The bottom of this one is going to be above the top edge of this one. Okay, so the bottom edge of this is going to be its y value plus its height. So let's say, I know I messed up these numbers. Let's say rect y plus rect1 dot get height. That value needs to be, so it needs to be above. That actually means in our coordinate plane, it's going to actually be smaller than. That this line, the value of this y will be less than the value of this one. So we're going to say that this is less than rect2 get y. Okay. So we're getting closer. One step closer. Hopefully this is making a long video, but that's where we're at. All right, so now we can see if we're if we're anywhere around the top, if we're kind of crossing the middle, as long as we're kind of staying above the top, it's not detecting it. But then, of course, down to bottom we are. So let's do our very last one. We want to check to see if the top of this thing is below the bottom of this one. So the top of this one's pretty easy. It's just going to be the y value. So let's just say our rect1, oops, not like that. We're going to say rect1 dot get y has to be below. So that actually means the value is going to be greater than, this value is going to be greater than this one. This is going to be our rect2 dot get y plus rect2 dot get height. Okay, and that's going to be it. So if any one of these things are true, we know they're not overlapping. If none of these are true, then we're going to return that yes, they are in fact overlapping. So we can check that here. Nothing's touching. As soon as we cross over a single little bit, it's going to set this off. All right, so it's a bit of a long video. This is like a super powerful thing that you can use. Again, if you just want to copy and paste my code into your work, that's fine. You should know how it works because you're going to have to manipulate some stuff with it. But it is something that you can definitely just copy and paste. It, again, does not count towards the total number of methods you need for your project, but it is an option for you.